So in this video, we are going to compare the three models that we created using trend lines. So we have the linear model, we have the exponential model, and we have the power model. What we want to do is to check how well these models fit the data. So what we will do is we will push values for x. So x in our case is the price. So we're going to push all this model, all these numbers, price, through each equation, and we get a demand. Now this is the predicted demand based on each model. And we are going to compare the predicted demand to the actual one. So in this case, the actual one is what we recorded historically. So to do that, we have to organize a bit of, we have to organize the area where we're going to do that. So we've got three models, and these three models have these equations, and we need to use them to calculate. So we need to push x, and we need to get a y. So let's start with the linear model. So I'm going to copy this equation, and I'm going to go to the modeling section here, and I will say that this is the linear model, and the linear model is this equation. Oh, sorry, I think I need to copy only the text. Let me go back here, and inside here, I will just copy the text, Control C. So I've double clicked on that label just so that I can copy the text. And I go back in here and I paste the equation. So that's my linear model. And you can see that this linear model has two values that I'm interested in. So it's of the type y equal bx plus a, right? And we refer to b as the slope, and a is our intercept, basically. So I have two values that I'm interested in, b and a. So who is b? Well, b is minus 0.354, and a is 211.31. Okay, so that's my linear model. And I need now to, so what I'm going to do is just to clean this one up a little bit. I will merge and wrap in this cell and just make it a little bit fatter so I can see all the data that I want to see. So that's my linear model, and then let me center it. So that's the linear model I'm looking at, and is basically written in this way. Okay, maybe what you can do is make some spacing or some new lines so that the data looks a bit better. So to do the new lines, I use Alt and Enter. So I go on in the cell next to the place where I want to put a new line, and I do Alt Enter, and that's going to now display this nicer. And if you want to see everything, just reduce the size a little bit. So you can see that, oops, sorry. I have now, I can see my model, and I'm going to make it bold. Okay, so I've done with the linear model. What I've done is I simply created a section where I can now use this to work with the equation. So what I want to do is to push x into that equation. So to do that, I would need to calculate a predicted demand. Okay, so one way to do this is to simply copy all the data further down. So let me do that. I'm going to copy the data here, and let's change the size of the data. So, and I'm going to change the label. So this is actually the real demand, or the historical. Yeah, so this is the historical demand that I am given, I've observed. I'm going to wrap the text in there. So That's what we want. What I want to calculate is the predicted demand. Yeah, and in this case with the linear model. So I want to know, based on my model, what demand is predicted for the prices that I see in here. Okay, so I'm going to format, so copy the formats onto this column as well, so it looks okay. Now, how do I calculate the predicted demand? Well, I have to push X into this equation. So I have to write something like this. This is equal to what? B times X. So this is where B is. B times X. Well, the X is the price. So I'm going to say this is the price times the slope plus, that's the equation, bx plus a. So a is the intercept, and I put the intercept there. And this is going to give me now a demand that is predicted by my model. So my model is estimating that when the price is 450, the demand is going to be 4,500. And sorry, 5,200s, but the reality was that there were 4,500s. Okay, so there is a difference. There is a difference between the predicted and the real. And what we really want is that this difference to be as small as possible. Because if the difference is small, then our model fits the data better, is better at predicting reality. How do we calculate that difference? Well, we simply have to take the difference between the two. So let me calculate here the error. So we call this the error for the linear model. And as before, I'm going to format this in the same way. So copy the formatting. So what's the linear error? Well, the linear error is what? The predicted minus the real. That's our error. 7. So 700 units. Okay, now I need to do the same thing for the next month. I have to calculate the predicted demand using the linear model, and I have to calculate the error using the linear model. In Excel, we can drag the formulae. So I can choose to copy or drag the same formula here. But if I do this, so when Excel copies something down, what will happen is that when you copy, for example, the formula from row 26 to row 27, then all the references to row 26 will be changed to row 27. So in this example, if I have B26, it will become B27. And if I have B22, it will become B23. And B23 will become B24. So basically all references to row numbers will be incremented as you copy the formula down. And similarly, if I was to copy the formula across columns, then the column names will be changed. So to avoid that, because of course we don't want this B22 to become B23, because B will always be B. It shouldn't change. It should always stick to reading B from row 22. So to do that, you fix the row. So this is telling Excel, if you copy this down the row, 22 will remain 22. And to do that, you add a $sign before the number. So I want to fix B22, and you guessed, I have to also fix B23 because the intercept, or A, always comes from B23. And I don't need to change this one. I don't need to fix this price because I want the price to change. As I copy this to 27, I want to read the price from 27. And if I copy to row 28, I need to read the price from row 28. So this has to stay the price as it is. So I hit enter, and I can now copy the formula down. And you can see that when I copy the formula down, you can see how those B22 have remained fixed. B22 remain fixed and B23 remain fixed. And the only thing that is varying is the actual price, which is the one we read as we go down across the row. And let's do the same for the error. Now the error doesn't need to really fix anything because I always want to take the difference per row. So I want, if I copy this down, to become D27 minus C27, right? And the same, if I copy down to the next rows, it should also change to give me what I want, the difference between the predicted and the real demand for each price that I have. So I'm done with the linear model. I have just used the linear model to predict demand, and I calculated the error in demand. Let me put that one in there for the linear model. And to be consistent, let's put the brackets in here. Now what I need to do next is to do the same thing for the other two models that I have. So I have the demand for the exponential model and I have the demand for the power model. We have to do exactly the same thing. So I'm going to stop this video now to allow you the space to do this task.